So let's go through and take a look at one of each type of problem that's going to be in your functions. Check 3. They're not going to be necessarily exactly the same, but the same type of idea. So we can just sort of review each content area. If there's a specific area that you're missing or a specific type of problem that you continue to mess up on, feel free to fast forward, rewind, sort of whatever you need to do to get to the problems you need to look at. So the first type of problem that we are going to consider is a system, right? It's when we have two equations, two functions given to us, two variables, and we want to solve for both x and y. So there are multiple ways that we can solve systems. This particular system is already kind of nice and neatly set up where everything is stacked. We have the x's, we have the y's, and then we have the constants. So remember, when everything is sort of nice and neatly stacked in this format, we want to look to see if we can find a place where we see a variable that has a matching number in front, and also where it has one being a positive and one being a negative, right? We want the variable to have the same number, but for the number to be the opposite sign. Okay, so if we look right here with our x's both have a 2 sitting in front of it. So we then want to see if they both have the same sign or if they have opposite signs. So this top 2 is positive, and this bottom 2 is also positive. So because those are the same sign, we're going to head and go through and multiply one of those lines by -1. Doesn't matter if it's the top one or the bottom one. So our top equation is going to stay the same, since that's not the one I chose to multiply. It's going to stay as a 2x plus 4y equals 22. Okay, and our bottom line is going to become a -2x plus a 2y equals 8. Okay, and then from this point, we are then going to, we have matching numbers in front of the x. One's positive and one's negative. So now we can ignore what we had over here and just add straight down. So 2x plus -2x gives us 0. That cancels out, which is what we want to happen. 4y plus 2y gives us a 6y. And 22 plus 8 gives us 30. Now we have a one-step equation that we are able to solve. And we get y equals 5. Now, we're not finished at this point because we need to solve for an x and a y, which means at this point we've found the y, but we still need to take this y value and plug it back in to one of the equations. Doesn't matter which one we're picking, as long as we're plugging it in for y. So now instead of saying 2x minus 2 times y, I'm going to say 2x minus 2 times 5, because we now know that y is equal to 5. So I have 2x minus 10 equals -8. And now I just have a two-step equation that I need to solve. Okay, and so I will get x equals 1. So at this point I know that my x value is x, my y value is 5, and so I could write my answer as an ordered pair of 1, 5. Okay, the next type of category that we need to look at is we need to be able to interpret solutions of systems of inequalities. So we know that when we have a system of inequalities, okay, we're going to graph answers on the coordinate plane. So maybe if we have something like y is greater than 2x plus 1, right? So I'm going to go to 1 and then up 2 over 1. Okay, this type of inequality greater than says it's not equal to, so that would be a dashed line. And greater than tells me to shade above. And then maybe the other one that I have is y is less than or equal to -3x minus 1. So I'll start down 1, and then I'm going to go down 3 over 1. All right, down 3 over 1. I'm sort of approximating here, but we get the idea. This one is going to be a solid line. And this one we would shade below. Okay, now our final answer when we're graphing systems of inequalities is where those two overlap. So where do we see orange and black at the same time? So anywhere that we see the orange and the black happening, all of this area, okay, is part of our final solution. Which means any place that we are either on the solid line as part of the border, or inside the overlapping area. It doesn't count over here because it's a dashed line. Any place over here counts as a final solution. Not where we just see black, not where we just see orange, and not where we see nothing at all. Okay, we are also going to have things with function rules, okay, whether they're written as a function rule or as in function notation, and then finding values in a table. So I'm going to just keep to a short table. Maybe I have values of -5 and 5, and I'm going to say that my function rule is f of x equals x squared plus 7. Okay, if I want to evaluate this for -5, I'm going to take that -5 and I'm going to plug it in for my, oops, this should have an equal sign here. I'm going to plug that in for my x. Okay, so f of -5 is then going to be -5 squared plus 7. The key is that this -5 has to be in parentheses, right? I want that entire -5 squared. So whatever value I'm plugging in is going into parentheses. So if you're typing this in your calculator, you are going to have to include those parentheses or you will get an incorrect answer. Okay, so -5 squared is 25 plus 7 will give us 32. Okay, and then we will evaluate this at 5. So now we'll say f of 5 equals 5 squared plus 7, which is also 32. Okay, so just making sure we're getting those parentheses in the appropriate locations. Okay, we also then need to do some things with writing equations of lines. So a couple things to remember about writing equations of lines is that if we are given m and b, so if we know information about what m equals and about what b equals, then we can plug into y equals mx plus b form. And so if m is 4 and b is -3, I could just say y equals 4x minus 3. Okay, if I am given information about having an undefined slope, right, we can't plug in the word undefined. So if we have m is undefined and it passes through the point -2, 7, we have to know that undefined slope is a vertical line. And all vertical lines are x equals a number. So as soon as we read that it's undefined, we are writing down x equals, and then we're looking to see what x equals in this particular problem. This is an ordered pair. So our x value in this ordered pair is -2, and so our equation would be x equals -2. We can also write equations of lines if we are given a point and a slope. So if I know what my slope equals, and I'm given a point that it passes through, right? If I'm given a point and a slope, then I can plug into point-slope form. And all of these formulas are listed at the top of the functions check. So if you don't have it memorized, you can look at the top to get the formula. Okay, so we'll start plugging in. Y minus my y coordinate, right? This is an x sub 1 and a y sub 1. So y minus 9 equals 4 times x minus x sub 1 is -1. So two negatives make a positive, right? And when we write equations of lines, we don't leave them in this format. So we would distribute. So we get 4x plus 4. And then we'll undo subtraction with addition. And so our final answer would say y equals 4x plus 13. Okay, the last thing that we need to be able to do for this assessment is we need to be able to remember some key pieces about graphing. So we can graph in different forms. So if we're given something like y equals 1/2 x plus 3, okay, we need to know that when we graph this, our starting point is the y-intercept. So we would start at 3, and then we would go up 1 over 2. Now, we've looked at graphing in all different formats. So if we're given something in another format, we then have some choices to make. So if we are given something in point-slope form, okay, we can either remember that in point-slope form, we have an ordered pair where it's the opposite sign. So it would be -6, +5. Right, and my slope is going to be 2/3. And we could plot that point and count the rise over run. Or we could say, oh man, that's been a while, Miss McKinney, I really don't remember how to do that. We could also then look at this and say, okay, I forget how to deal with point slope form, but I do remember how to solve this for y. So instead we could choose to solve this for y, and it could become a 2/3 x plus 4. Could finish solving. And then we could just graph in its slope-intercept form. So even if you don't remember every single detail of each different form, we can take some new skills that we've added to turn it into a form that we do know how to graph it. Okay, so hopefully this helps you get over some of the stumbling blocks with the function check 3. If you have any other questions, feel free to come to core time and we can look at some other examples.